Alright, welcome back. So today we're going to look at a v-t graph with all constant velocities, meaning the object is not actually accelerating. It is still moving, but it is not going to have any accelerations, meaning no slopes. Okay? So some things we need to understand when looking at a v-t graph is, what do we know? The first thing I can tell you is the direction of motion of the object. And in order to determine that, I have to look at the object's velocity, meaning the y-axis. So if I look at the first line segment, this line right here, I know since it's below the x-axis, meaning a negative velocity, that is moving to the left. Okay? I always reference negative as left and positive as right, just to give you an idea. Okay? So I know the velocity of segment 1 is negative 18. The velocity of segment 2 is going to be positive 18. The velocity of segment 3 is going to be positive 30. And I've labeled my scale for you. It's going by sixes, by the way, just to give you a heads up. Segment number 4 is moving left with a velocity of 6 meters per second. Segment number 5 is moving positively or to the right at 24 meters per second. And segment number 6 is traveling to the right with a positive 6 meters per second. All right, so now what else can I determine from a v-t graph? Well, I know that the area underneath the segment, or between the segment and the x-axis, if you will, is going to represent the displacement. So I like to draw in my areas. Since we have all constant velocities, we have all rectangles. The area of a rectangle is going to be base times height. So, area of the first segment, we're going to take the base, which is the time, which is 3 seconds, and multiply it by the velocity, which is the height, which we already know because we wrote them all down. Now, in order to be accurate, you must leave the direction, because displacements have a direction. They are vectors. Segment number 2, the base is 5 and the height is positive 18. For the third segment, 5 seconds times positive 30 For the fourth segment, also 5 seconds times negative 6 equals negative 30. For the fifth segment, we are going 7 seconds for positive 24. And the last segment is 5 seconds at positive 6, which is positive 30. Okay, now you have all of your displacements. In order to find more information, right, did the object go left or right of its starting position, things like that, you can use the information now that you've found, okay? If I asked you for the total distance the object traveled, you would take all of the displacements, remove the direction, and add them together. If I asked you if it ended up to the left or right, you would take all of the displacements, add them together, and if it's negative, it ended up to the left. If it's positive, it ended up to the right. Okay? I hope this helps.